Okay, now let's look at another aspect of the Keynesian cross model. In particular, what we're interested in here is seeing what happens when there is a change in an autonomous component of expenditure. So we can see here is our Keynesian cross model, and we've got total expenditure here. The economy is in equilibrium at 500 income, 500 expenditure. And what we're interested in is seeing what would happen to our economy if one of these components, domestic consumption expenditure, domestic investment expenditure, government expenditure, or net exports, which is exports minus imports, were to change for reasons that have nothing to do with a change with income. That is to say, what if one of these components of expenditure changed independently of income? We've already seen how consumption expenditure in particular changes because of a change in income, but here we're talking about what if one of these factors changed first, was the causal factor, so to speak. For example, what if we were to assume that consumers suddenly felt very confident about the future, and so that they decided to spend more than they did before, even though their incomes hadn't changed? Or if businesses became very upbeat about the future, and they thought the future looked very bright, and so they decided to engage in a lot more investment expenditure, building more offices and factories and buying more equipment and so on. Or maybe the government might decide to increase government expenditure and launch a large infrastructure program or something like that. Or there might be an increase in demand for Australia's export goods, independent of what's happening with our economy, which would increase overall expenditure. All right, so we're imagining a situation like that. What would happen? Well, we would shift the total expenditure curve upwards by the amount of the initial increase in autonomous expenditure due to one of those factors, whichever one in the story you want to tell. So it pushes the total expenditure curve upwards, like this, pushes it vertically upwards. Okay, and now we can see that the first step is to say that the economy now would be in disequilibrium. We can see that initially at 500 income, the expenditure now would be 600. So the economy is in disequilibrium. We've got a gap between expenditure and income. And we know when that's the case, when expenditure is 600 greater than income or the value of production, firms realize that they are now producing an insufficient quantity to satisfy demand, and they will expand production. So we'll get an increase in production, and therefore an increase in incomes, and therefore households will increase their expenditure. They will then move along their expenditure line until we get to a new equilibrium. Voila. So we have a new higher GDP and higher expenditure. All right, so we can see how an a change in one of the autonomous components of expenditure can cause an increase in GDP, can cause what we can call economic growth to occur in the short run. So far, so good. Let's put some numbers on that and see something interesting. How much did we increase expenditure by? You can see there we increased expenditure by 100. The expenditure curve shifted upwards at every point on that curve, shifted upwards by $100. Or make it, more realistic, $100 million, say. All right, the increase in expenditure of $100 million resulted in what change in income? See, income rose from 500 million to 750 million. That's an increase of 250 million. A 100 million increase in expenditure resulted in a $250 million increase in income, the value of production. So why would that be the case? Something's going on there. We could say that the initial increase in expenditure has been multiplied to create a larger increase in GDP. This is called the multiplier effect. A change in an autonomous component of total expenditure will be multiplied by a factor of K, by some factor, as that expenditure circulates around the economy to generate, ultimately, a larger increase in income. That is, a larger increase than the initial increase in expenditure itself. So we can express it in a nice, simple way like this. The change in expenditure was multiplied through the economy by K to give us a change in income. In our example that we used previously, that's a $100 increase in expenditure, $100 million increase in expenditure, was multiplied 2.5 times as that money circulated around through the economy to generate an increase in income overall of $250 million. Okay, so briefly, how does this multiplier work? How is this multiplication occurring? Well, let's make it a very simple story. And we'll start off with, let's say, there is $100 million invested, increase in investment expenditure in the economy. This is an autonomous change in expenditure. Now, that expenditure that's not the end of the story. That's only really the beginning of the story, because that $100 expenditure becomes $100 income for those people who receive the $100 to build the offices and the machines and the new factories and so on. Now, what do those producers do with their $100? With that 100, I'm just going to say $100 from now on instead of 100 million. What do they do with that $100? Well, if we keep it nice and simple, they do two things with it. They save, let's say, 40% of it. That's $40. And they spend on domestic consumption 60% of the $100. That is $60. So far, so good. Side note, these percentages are known as, this 60% of the increase in income is known as the marginal propensity to consume, and the 40% of income which is saved is, surprise, surprise, called the marginal propensity to save. So, what happens then? Is that the end of the story? No, not by a long shot. Because the 60% that's spent, of course, is spent on, for example, buying new cars and washing machines and things like that. So that becomes $60 income for yet other people. And what do they do with that income? Well, they save 40% of it. So that'll be, let's see, $24. And they will spend the other 60%. Consumption, 60%. The marginal propensity to consume being 60% of the income. So that's $36. What happens to that $36? That's spent on goods and services, which means that that is $36 for yet another group. Who will do what with their income? They will save 40% of the $36. That's $14.40. And they will spend on consumer goods the other 60%. Their marginal propensity to consume being 60% or 0.6. $21.60. That $21.60 which is spent is obviously income. $21.60 is income for yet another group of people. They save 40% of the $21.60. So that's $8.64. And they will spend 60% of that $21.60, which is $12.96. And that spending is obviously income for yet another group. $12.96 income for yet another group. And so on and so forth. All right. Now, what has happened overall to income? Well, it's increased by 100. Then, in addition to that, we have to add, it's increased by another 60. And then we have to add to that, it's increased by another 36. And then we need to add to that, it's increased by another $21.60. And to that, we need to add, it's increased by another $12.96, and. So we can see that this income is being multiplied. It's increasing. But it's increasing at a decreasing rate. How would we find out, well, what's the total increase in income overall? Well, we could, if we wanted to, we could do it in an Excel spreadsheet and just work it out that way. Or we could do it by hand this way forever and ever. Or alternatively, what we could do is we could calculate it using the equation we've already seen. The change in autonomous expenditure, and I'll indicate autonomous expenditure with a little O, a subscript 0. Change in autonomous expenditure times the multiplier equals the change in income overall. The initial change in expenditure was 100. the multiplier is 2.5, and that results in, if we add up all of these, the overall increase in income is 250. Easy. Our next question, however, is it that simple, really? Well, surely there's more to it than your income is either spent or saved. Aren't there more leakages than that? And the answer is absolutely. So let's do it again, but this time I'll leave out the numbers, but you'll get the idea. So we've got our initial change, let's say it's an increase, initial increase in autonomous expenditure, let's say it's investment expenditure, leads to an increase in income. Now, of that income, before anything else happens, some of that income, well, let's make our story more realistic, some of that income is lost in tax. So the household has to deal with their disposable income, that is their income after tax. So their income after tax, so this is now an increase in their income D, that is their disposable income, their after-tax income. And of that, they save a bit of it, they spend some of it on imports, and the rest they spend on consumer goods. Now that increase in consumer good expenditure is income for another group, but some of that is taken in tax, so that other group is left with higher disposable income. They save some of it, they buy some imports, and they spend the rest on local production, consumer production, which is income for another group. But some of that is taken out in tax, the rest is saved, some is spent on imports, and the rest is, and so on. The point here that I'm trying to make is that there are more leakages in this story. We've added the leakage of tax, and we've added the leakage of imports into our story. And because we've added these additional leakages, these additional withdrawals, the increase in consumption expenditure will be less at each level. And therefore the overall multiplier effect, the multiplier will be smaller, and therefore the overall multiplier effect will be smaller, because remember the multiplier effect relies on increases in income generated by increases in consumption in from the previous group. Now, if the income generated, some of it's taken away in tax, and the rest of it and some more is taken in savings and imports, it's leaving less for consumption expenditure. So overall, the multiplier effect is going to be smaller because there are more leakages from the system. So we've seen in our example that the initial change in increase in investment spending multiplied through the economy led to an increase in income of 250. What we should also note about that is that one important thing is that this works in the opposite direction too. If there were a $100 decrease in investment spending, that too would be multiplied through the economy to result in a larger decrease in incomes. So this multiplier effect is a double-edged sword, so to speak. But one question that should be lingering for you is this K. How do we calculate this multiplier? How do we know it's going to be, in our example, it was 2.5. What determines that multiplier? Well, it depends, as we saw, the size of the multiplier depends on the number of leakages there are from the system and the size of those leakages. Now the leakages come in, as we already talked about, there's savings, there's import spending, and there's taxation. So we can say we've got, there's what we can call the marginal propensity to tax. That means there's some percentage of income that will be taxed, which we can represent, that percentage of income which will be taxed, we can represent by a lowercase t. So for example, it might be 20% of income, or in other words, 0.2 of income. So we'll represent that by a lowercase t. Then we've got the marginal propensity to import or purchase imports. And we can represent that with a lowercase m. So that means when income rises, some percentage of that income will be devoted to spending on imports. So let's say, I don't know, let's say, it could be 30%. 30% of the disposable income will go to spending on imports. And we might have, and then we've got savings, and we've already seen that that's the marginal propensity to save. The marginal propensity to save out of disposable income, that is after tax income. And we can represent that by the letter small s if we wanted to. But that's not so important here because it doesn't really, it's reflected in a different way in the equations that we're going to see. All right, now bear those things in mind. I'll show you something. I'm not going to explain this in detail. I'll save that for another lecture or another video. But let's just say, if we made our economy a very simple economy in which households could either spend or save and that's it, there's no taxation and no imports, then the multiplier K would be calculated by 1 over 1 minus little c. Little c is the marginal propensity to consume. So that was in our previous example, that was 60% of 60% of income. Okay? So that's, in our previous example, that was 1 minus 0.6, 60% of income. That's 1 over 0.4, which is 2.5. Yep. The larger that the marginal propensity to consume gets, the smaller the denominator gets, and therefore the larger the multiplier gets, the larger K gets. All right. So that's for a very, very simple economy. But what if we wanted to make it more complicated? What if we wanted to add taxes to our system? So, with taxes, in that case, our multiplier would be 1 over 1 minus the marginal propensity to consume plus the marginal propensity to consume multiplied by the marginal propensity to tax. And lucky last, what if we want it with tax and imports? In that case, our multiplier would be 1 over 1 minus the marginal propensity to consume plus the marginal propensity to consume multiplied by the marginal propensity to tax plus the marginal propensity to spend on imports. So these are our three possible multipliers that could be used depending on how simple your version of the economy is. Obviously, the more complex version of the economy would utilize this kind of multiplier. So just to give an example, briefly, let's say the marginal propensity to consume is 0.6 out of after-tax income, and the marginal propensity to spend on imports is 0.3. So for any increase in income, 30% of it will be spent on imports. Any increase in disposable income, 60% of it will be spent on consumer goods. And let's say the marginal propensity to tax is 0.2. So any increase in income, 0.2, 20% of it will be taken in tax. So our multiplier is going to be 1 over 1 minus marginal propensity to consume plus marginal propensity to consume multiplied by the marginal propensity to tax plus the marginal propensity to spend on imports. So that's 1 minus 0.6 plus 0.6 times 0.2 plus 0.3, which boils down to, always do this first and then the remainder, boils down to 1 over 0.82, which equals 1.22, rounded up second decimal place. So that's our multiplier. Okay, easy. So if, for example, we had an increase in autonomous expenditure by 100, we would multiply that by the multiplier, which we've worked out is 1.22, and we know that the result is going to be an increase in overall income of 122. Voila!